Hi there guys, this is Maitri Patel and we are back with another assignment for applied machine learning. So let's not waste any time and let's get started. So in this assignment we have to train data for iris. So in first it says that I have to put my iris file on my Google Drive, which I did over here. So I got my access from Google Drive by mount. After that, I imported pandas as PDF, and in that, it says that we have to find the part of iris.csv file and save it in a variable called file name. So I did the same thing over here. For this, I found the path and I pasted it over here and saved it on under the variable name called file name. Moving ahead, so it says read the content of the iris CSV file and save it in a variable named iris. So I did that over here. I named it as iris is equal to pd read CSV file name. So I put file name over here so it could directly give us the paths for which I have put over here. Moving on to it says we have to show the first 5 rows of the data frame. So I just simply had to put iris.head and it would show us the first 5 rows of the data frame, as you can see over here. So after that it says we have to work on neural networks and we have to change the string into integers. As you can see over here, it will change like setosa into 0, where versicolor into 1, virginica into 2. So over here, so over here I simply did iris bracket dot species and it means the column name. So after that I put iris species and then dot map setosa, where versicolor and virginica. But for that, as you can see, I have put over here for setosa it would use 0, for versicolor it would use 1, and for virginica it would use 2. So after running that, over here when we have to check the first 5 elements of the iris data set once again, so for that I put it over iris.head, and as you can see the species it all converted into 0 because this is all setosa. So because of this code we converted it into 0 into numerical numbers. Like over here, as you can see, it's written not in integers, but after we converted it got written in this. So we can do it we can put maybe 120 columns something, and check it if we can see the other ones. And yeah, see, as you can see over here, the code did run well, because now we can also see that we also got virginica over here, as you can see, and it got converted into numerical numbers. So yep, let me just remove this. Yeah, so moving on, for the third one, it says select the first 4 columns of the data frame as the data and call the data x. So for that I used ilog, so it's iris.ilog, and then I put the first 4 values over here and put it in x. So as you can see, I got the first 4 over here in an array. So as you can see it over here, it's once for sepal length, sepal width, petal length, and petal width. I got it all four over here in the form of an array, as you can see. Yep. So and the third so in this question it says select the last column as the label and call it y. It's the same thing as up, but we just have to put y, and for the last column we used minus 1, so it would take care of the last column. So after that we can find this array over here, as you can see. for this last column over here. Yep. So yeah, we got it in array. So after that, now it says now it is the time to split the data X and the label Y into training and testing segments and call them parts X train, X test, Y train, and Y test. So please split the data and label into training and testing segments. While the size of the test data is 20% and use random state 1 to 3 to make all the answers similar in the whole class. So for that, I've used the sklearn method and the split one, that's an inbuilt method. I've used that. So for over here, as you can see, I put 0.2. It would like convert it into like 20% for it. And so for this X, it's like a training data, and this one is like comparison labels for Y train. So it would give us the answer as we would see it down. So it says please check the first 5 rows of X train, X test, Y train, and Y test. So I checked it over here by X train and X test, as you can see, and yeah, we got the answers for it. But for like then if we move to the like check the length of X train and X test for 120 and 30. So if we got that, we are good to go. So over here, when we put the code over here, the training data and the comparison label for the Y train, and I put it over here, the inbuilt function. So with that function over here, when we check, we get this thing. We get for length, we get 30 for test length X test, we get 30 for train, we get 120. So it's a 120 and 4. So it's good to go now because it's written in the question. So if the numbers are 120 and 30, we are good to go. Okay. So next, it says please convert to Y train and Y test into categorical and call them one hot train labels and one hot test labels respectively. So in this, I used the inbuilt function in here for the two categorical, and I imported it from tensorflow.keras utilis. So we just need to put them in this function. So it will turn automatically into them. After that, it says please define a sequential model that contains 3 dense layers. So let me just just a minute. Okay. So for that, in applied machine learning, we put the first layer and it would automatically take the second layer output as input. So for in this thing, I already put the sequential model over here, but as you can see, for it says in the first and second layer use 100 hidden units and a ReLU activation function. So I have used it over here, and for the last layers you need to use 3 as the number of output, and the reason if we have 3 classes. And so also please pick an appropriate activation function for last layer. So over here I use the sequential model, and after that as written in the question, we have to put 100 hidden units. So I put it over here and the activation ReLU over here. So wanted to say that if we put the first layer over here, it would automatically take the second layer output as an input. So it's so for over here it says an appropriate activation function for last layer. So in this I put for like if you need any probability, softmax is the best for it. So I just used that for the last layer as an activation, so we could get the best results from it. So it says now please compile your model using RM as prop an appropriate loss function and accuracy for your matrix. So yeah, let me just uncomment this. Yeah, and yeah, so we compile it for that, and as usual I've put like categorical cross and trophy because it's the best thing to put it. After that, it says place feature model using epoch 20 and batch 10. For that, okay. So for that, I over here, as you can see, I put model fit X train and one hot train labels and epoch into 20 and batch size into 10. So it would give me the results for it. The accuracy would be around 0.97 and the loss would be around 0.12. And after that, after doing that, over here it's written please calculate the result evaluating your X test, one hot test table, and see how accurate your model works. So for that, let me just, yep. Yeah, so for that, as you can see, I put the test accuracy and test loss over here to evaluate, and it shows pretty good of it, like the test accuracy is 0.96 and it's pretty good. The test loss is 0.14, and that's good too. And that's how accurate this model would work. So now we have to repeat all of this we have done and 6, and with the following parameters. In the first and second layer use 10 hidden units and a value activation function, and for the last layer we need to use 2. So for the upper ones we had to use 100 of it, as you can see over here. Now we have to change it to 10 in this next one. So for to get these answers for this, we have to first comment those and uncomment this. So this is already uncommented, just need to comment this once. So let me just do it. Yeah. Okay. Over here, this. Okay. So now by commenting those and uncommenting this, the same thing that we wrote upside. So we just have to put 10 instead of 100 over here, 10 hidden layers, and see if that works. And already we put categorical cross and trophy. So for that, as you can see, and give us 95 over here and 41 over here. Let me just do it again to maybe get some good accuracy in it. Yep, 96. Yeah, that's pretty good accuracy for that. And so for here, if we calculate the result evaluating our X test and one hot test table, so our model would work like this. So the test accuracy would be around 96 and the test loss would be around 0.111, and it's a pretty good result. So after that, we have to answer some questions. So it says please explain all you have learned from this assignment. So let me just put this question, and I'll just answer this question in the last. So after that, it says how the number of layers or hidden units could impact the accuracy of our model. So it can impact us pretty well, as we can see if we use 10 as hidden layers for number, and if we count the accuracy and loss, and after using it for 100 and counting it, it would be a wide difference, so it would impact too much. After that, like it says, do we always have to suffer from overfitting? So right now, as we can see up what I did, right now I can't say that we are suffering from overfitting because more layer is giving us better results right now. So next it says, how can we find and manage overfitting? So we would find it in a minute. Let's just do this for that. So for this, it says please try different seasoning, and if we did in 9, and you can change the number of layers and hidden units. So for this, I didn't change any optimizer, any loss or matrix or any activation function, because softmax is the best for better results. So I did put it as it is, but I changed the number of layers for it. So as you can see, I changed it to 60 from 100. Over here 60, 60 and 3. In the upper one it was 100, 103. I changed the hidden layers in this to find the best accuracy. So after like running it, as you can see, we can find the best accuracy. This is around 1, and like it seems perfect. It's about to go near that. So after changing the one from 100 to 60, we can now get the best layer, best accuracy, and this algorithm that we use for it, it's the best. So for now, going back to the question over here, it says like, do we always suffer from overfitting? So for now, for first I said like we didn't suffer it when we were having 110, but now we can say that we are suffering from it, because now we have to compare the algorithm. So for with the hidden layers, so if we compare the hidden layer with like with 10, the 100 hidden layers with 10, so then we wouldn't be suffering from overfitting. But if we compare it with 60, we would be suffering a little from overfitting. So first it was not like that, but as we change the layers, it can be like that. After that, now it says how can we find and manage overfitting? So how to find it? We just try to get like the best accuracy by adjusting some hidden layers, and to manage we have to cut some hidden layers. So because if we do too much epoch, the algorithm will train too much for its training data. So for it, when we give new data, it can't do better because of training too much. It gives us an unwanted patterns which we do not want it over here. So for that, we don't need those patterns. So for assuming any labels for testing data, we don't need that. So that's how we like find and manage the overfitting. So moving on to the next question, the question that I told I would answer it in the last. Please explain all you have learned from this assignment. So from what I believe, I think this is the best example for overfitting. So let's say for an example, if we start training data, we train the data once and it is trained, and we got the results, which was good results. But for making it even better, we have to adjust something. So in this we adjusted the hidden layers. So from 100 we put it to 60 to get like the perfect output that we need. So when we train any data or algorithm, we just need to be sure that we are not doing overfitting, because if we do it in the algorithm, we can't perform better for new data that's coming. So from my experience, it's a very good example for overfitting, and I learned a lot from it. And I think that is it. Hope you liked my video, and thank you for watching. And meet you next time with next assignment. Till then, bye bye.